Now we are going to be adding and subtracting rational expressions when we don't have a common denominator. So sorry, that got really bright. I don't know what happened. Okay, so what I want to look at first is these two pieces of chocolate. So if I want to add these two pieces of chocolate together, right now it's kind of tough because this one's like long and skinny and this one has more width to it, correct? So it's tough to add these two pieces of chocolate how they lay. So if you're looking at them like this, that's a little confusing, but if I flip them over, this video is not endorsed by Hershey's. If I flip them over, you can see that this one has 3 sections and this one has 6 sections, and it's easy to see that there's 9 sections of chocolate here. So when I put them in equal pieces, it's easy to see what I've got. But this way, it wasn't as easy to see what I've got. So the same thing works when we're adding fractions. The denominators are telling me what I've got. So the first thing we always have to do is get a common denominator. Always, 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 always we have to get a common denominator. It's going to be your first step when you're adding and subtracting. Now yesterday, or on the last video, we already had common denominators, but as you can see on this one, we don't have common denominators. So the first thing we always are going to have to do is factor your denominators. That's not anything different. We had to do that last time too. So x divided by x minus 1 doesn't have any common factors, so I'm just going to leave it. 2x minus 1. Okay. Now here I have x squared minus 3x plus 2. So over here I'm going to factor that. X squared minus 3x plus 2. So AC method, and I am going to have 2x squared. So the stuff that gives me 2x squared are 1x and 2x. I'm trying to get negative 3 though. So there's no way that 1 plus 2 gives me negative 3, but if I make them both negative, now they give me negative 3, and multiplied they still give me positive 2. So that's what I'm going to replace it with, x squared minus 1x minus 2x plus 2. And we're going to group again, x and x minus 1. This, I can take out a negative 2, which would give me x minus 1. And then I can see that my denominator is x minus 2 and x minus 1. Okay, so again from yesterday, we were looking at common denominators. If you look at your first denominator, my common denominator, my first denominator has an x minus 1. My second denominator has an x minus 1 again, so I don't have to write that because that's not new, but what is new is x minus 2. So my common denominator is going to be x minus 1, x minus 2. So here's where it gets different. So what gets different is now we have to multiply each term by what is missing. So in this first fraction, I look at the denominator only. What's missing for my common denominator? Well, hope you can see that it's missing x minus 2. So we have to multiply top and bottom by what it is missing. So numerator and denominator by what it's missing. So now looking at the second fraction, my common denominator is x minus 1, x minus 2. It's got both of them. It's not missing anything. Okay, now before I go ahead and do any of that, I want to list any restrictions on the denominator. So where do I have variables in my common denominator? I have x minus 1. That cannot equal 0. So set that not equal to 0 and solve. We get 1. And x minus 2. Set that not equal to 0 and add. We get x cannot equal 2. Okay, now step 3 says FOIL or distribute in the numerator. So over here, back up in my problem, I'm going to distribute my x to the x and the minus 2. So x times x gives me x squared. X times negative 2 is negative 2x. And that's going to be divided by my common denominator, x minus 1, x minus 2. And then this one didn't change, so it's still going to be 2x minus 1 over x minus 1, x minus 2. Okay, now step 4 says add or subtract in the numerators only. So looking at my numerator, x squared has my biggest degree, so bring that down. My next largest degree is negative 2, or is x. So I have a negative 2x and a positive 2x. So those two are going to cancel. And then I need to bring down this minus 1. Now notice it says add and subtract in the numerators only. Keep the denominator the same. So my denominator is still going to be x minus 1, x minus 2. Now remember also, if it was subtraction, if this had been subtraction, we would have changed it to addition and changed both of the signs in the numerator after it. But since it wasn't, we just combine like terms. Okay, then it says the last thing, we need to factor the numerator. So looking at this numerator, I can tell that x is squared, 1 is also a perfect square, and with a minus in the middle, that's going to be difference of squares. And it's still over my same denominator that I've had since I got a common denominator. Now if you look closely at this, you'll notice that in the numerator I have x plus 1, x minus 1, and the denominator x minus 1, x minus 2. So the last thing is to cancel legally. Remember, to cancel anything, it has to have the same variable and the same everything else. So like this x plus 1 can only cancel another x plus 1. So I have an x minus 1 that can cancel this x minus 1. And my final answer is x plus 1 divided by x minus 2. And also my restrictions. X cannot equal 1 and x cannot equal 2. So all three of those things are your answers. Let's try another one. So if we look at this one, we notice, as soon as I get the page flipped, that I again do not have common denominators. So the first thing that I need to do is figure out what my common denominator would be. Well, to factor this, if I wanted to factor this, I could rewrite this as 2 divided by, and I could make a factor tree of 3. Well, a factor tree of 3 is just going to be 1 and 3, so that's not really helpful. I'm just going to make it 3. But I do have 2 x's, yeah? So I can write x times x. And then over here I have 5. A factor tree of 2 is just going to be a 2, and that has an x. So let's look over here at my common denominator. From my first denominator, I've got a 3, an x, and an x. From my second denominator, I've got a 2 and an x. Well, I already have an x, so I don't need to add another one. This x is not new information, it's already there. Okay, so multiply that together, and it is 6x squared. So now I need to multiply both sides by what they are missing. So this has a 3, an x, and an x. So you can either look at this line or you can look at this line. So it looks like from this line I am missing, or from this fraction I am missing a 2. And from this fraction I'm missing a 3. Is there anything else that I'm missing? Hopefully you notice that I'm also missing an x. So when I multiply these, I need to multiply the numerator. So that gives me 4, and the denominator, 6x squared. Then I also need to multiply the numerator on my other fraction. So 5 times 3 times x is 15x divided by 6x squared. So now that my now that my denominators are the same, I need to list any restrictions. Sorry, I probably should have done that here. So the only place in my denominator where I have an x is just an x, so x cannot equal 0 as my restriction. And now that my denominators are the same, I can finally add my numerators. So in my numerator, I have a 4 and a 15x. So are those like terms? Well, 4 doesn't have an x and 15 does, so they are not. You always want to put the thing with the variable first. Okay. And now I need to simplify. 15x and 4, do they have anything in common? Not that I can think of. And can I factor anything out of 6x squared? Nope. So since I can't, I'm going to write on here simplify, just so we remember that we need to do it. Simplify, no I can't. So that's my answer along with x cannot equal 0. Okay, next one. Do we have to factor our denominators is the first step. So if you look at this denominator, x plus 5, can I take anything out of that? X plus 3, can I take anything out of that? No, so the factoring actually in this one is done for us. But we always need to double check that we cannot factor. So factoring should be your first step. So since I can't factor, my next step is to, what is my next step? I got a little bit lost. Multiply by whatever is missing. Okay, so in my common denominator here, I have x plus 5 for my first fraction and x plus 3 for my second fraction. Okay, so this first fraction is missing x plus 3, top and bottom. So remember, you have to, whatever you multiply the top, you have to multiply the denominator, numerator and denominator. This next fraction is missing the x plus 5, so we multiply it, numerator and denominator. Okay, next I need to list any restrictions. So you can do that from the common denominator up here or over here. So x plus 5 cannot equal 0. X cannot equal negative 5. And x plus 3 cannot equal 0. So x cannot equal negative 3. Okay, my next step is to get this to be nice fractions so I can add them. So distribute or FOIL if we need to. So 3 times x is 3x. 3 times 3 is 9. And that is over my common denominator now, x plus 5, x plus 3. Now we're subtracting from that. Distribute up here. X squared plus 5x divided by x plus, and I'm just going to trade these since I have them x plus 5, x plus 3 over here, just so they're in the same order. Okay, so now what I need to do is add, but I can't add how they are. I need them to have, it's subtraction. So since it's subtraction, I'm going to change it to addition and change all of the signs that come in the numerator only after that subtraction sign. So after this, when I add and subtract, I'm going to look for like terms in the numerator and look for the largest degree. So the largest degree is x squared, that's negative, so I have negative x squared. Negative 5x and 3 is going to be negative 2x plus 9. And that is divided by x plus 5 and x plus 3. Okay, now the last step is to see if we can simplify. So can I factor in the numerator negative x squared minus 2x plus 9? Well, we never want our leading term to be negative, so I'm going to immediately factor out an x, or a negative. Okay, so when I do AC method, I'll have negative 9x squared. So what gives me negative 9? Negative 1x and 9x, and negative 3x and 3x. And that's all. So can any of those give me positive 2? No. So can I factor or simplify this? No. The only thing we might do is take out a negative just so our leading coefficient isn't negative. But that's as far as it can factor because the AC method doesn't work. So that, along with our restrictions, are our answer. Okay, more examples. So again, first step is to factor your denominators. So bring down your numerator. And looking at this denominator, what do you see that you can factor out? Hopefully that you see it has the GCF of x, and that would make it say x minus 2. And then we're going to subtract x plus 2. And in this denominator, what's our GCF? 2. And again, it would be x minus 2. Okay. So now what's our common denominator from that? Well, from this fraction, I have an x. and I have an x minus 2. This fraction I also have an x minus 2. That's not new information, so I don't need to write it, but this 2 is new information because it's not in parentheses being subtracted from x, it's out of the parentheses. So that's where it goes. So now I need to, remember you can't, just like the chocolate, I can't combine these until they are the same pieces. So I can't combine them until my denominators are the same. So right now this denominator is missing what from our common denominator? Looks like a 2. So multiply numerator and denominator by 2. And what's this one missing? This looks like it's missing an x. So numerator and denominator by x. So before I actually do any of the distributing, I want to see what my restricted values are. So does this 2x have an x? Yeah, it does. So we set it not equal to 0. So x cannot equal 0 divided by 2 is legal. It's 0. If we had been dividing by 0, that would not be legal. So x cannot equal 0 and x cannot equal 2. Those are our restrictions. So now we need to get our denominators to be the same. So to do that, we need to distribute or FOIL in the numerator. So 2 times x is 2x. 2 times 2 is 4. 2x times x minus 2 is what my denominator is going to be. Now over here in the numerator, I'm going to distribute the x. So x times x is x squared. X times 2 is 2x. And I'm still subtracting. Now my numerator, I have x times 2. I can rearrange them and put the numerator, or put the number first. So it looks like that. Now since this is subtraction, sorry, and I cannot subtract how this stands, I need to change this and change this to addition, and then hopefully you know that that changes the signs of both, or all, actually, all terms that come after the subtraction sign. So now all of the terms in the numerator that comes after the subtraction sign change. Now we combine our like terms, so we look for the biggest degree. The biggest degree is squared, so I'm going to have negative x squared. I have negative 2x and positive 2x, so that cancels. So negative x squared plus 4 divided by 2x times x minus 2. Then I need to see if I can simplify. Okay, so in the numerator, it looks like right now I have a negative x squared plus 4. Well, we talked about how you never want that leading term to be negative. So if I take out a negative 1, I've got x squared minus 4. Oh, what do you have when you have a perfect square minus another perfect square? Hopefully you know that that is difference of squares, which factors as x plus 2 and x minus 2. So can this simplify? Yes, it can. So the numerator will now be negative 1, x plus 2, x minus 2, and the denominator is still 2x times x minus 2. And then the last thing we need to do is see if anything will cancel legally. So remember, to cancel, it has to be the entire term. So x minus 2 and x minus 2 cancel. So your final answer is negative 1 times x plus 2 divided by 2x. Now, some people may want to cancel this 2 and this 2. They cannot be canceled because this 2 is being added to an x. So it could only cancel if I had another 2 being added to an x in the denominator. So that can't cancel. Again, and the x can't cancel either because it's being added to a 2. So it can't cancel with this x because it's being multiplied by a 2, not added to a 2. You have to have the entire term exactly the same in order to be able to cancel. Okay, next one. First step, factor our denominator. So this is going to take a little bit more work on the factoring part because it looks like with 3 terms I'm going to have to use the AC method. So I have x squared minus x minus 2. So the AC method, I am going to get negative 2x squared, and the way to get negative 2x squared is negative 1x and 2x, or 1x and negative 2x, and the way to get negative x is with 1x and negative 2x. So bring down your x squared, bring down your factors that you circled, and bring down your c term. Then we group and we get an x in common, x plus 1, and negative 2 in common, x plus 1. So it looks like this one, 2x will come down, and I will have x plus 1 and x minus 2 as my denominator, or whatever way you feel like writing it. You could write it either way, it doesn't matter. Minus 3. Okay, this one, I've got x squared minus 3x plus 2x. So again, I have, plus 2. There's not an x. So 2x squared, I was getting ahead of myself. So 1x and 2x, those don't give me negative 3x though. So the way to get negative 3 is if they were both negative, and does that still multiply to give me a positive 2x? Yeah, it does. So that one works. Bring down your x squared. Remember, this negative 3x gets replaced by what we circled. Group. I am group. X minus 1. And this one. Now this one's kind of tricky because it doesn't look like it has anything besides a 2 in common. But remember, my parentheses have to say x minus 1. And in order for it to say minus 1, I have to change this sign. So I have to take out a negative 2. So this is going to be x minus 2, x minus 1. Okay. Now on to our common denominator. So looking at our common denominator, from this fraction I have x plus 1 and x minus 2. For my second fraction, I have another x minus 2, so that's not new information. It doesn't go in my common denominator. But this x minus 1 is new information, so it does go over there. Okay, so what is this fraction missing? It has the x plus 1, it has the x minus 2. It does not have the x minus 1. That's a 1. It's disguised. Okay, so I need to multiply numerator and denominator by x minus 1. And this one looks like I've got the x minus 2 and the x minus 1. I'm missing the x plus 1. Okay. Then I need to look at my common denominator and see what are my excluded values. So we set all of these not equal to 0, and we get x cannot equal negative 1. X cannot equal 2, and x cannot equal 1. So 1, negative 1, and 2 are what my x cannot equal. Now I need to make these have the same denominator. So the denominator is going to be x plus 1, x minus 2, x minus 1, or whatever order you feel like putting that in. The numerator I need to FOIL, so 2x times x is 2x squared. 2x times negative 1 is negative 2x, minus, and x plus 1, x minus 2, x minus 1. And in the numerator I distribute, so I've got 3x plus 3. Now on here I have looks like subtraction again, obviously, so change this to addition, and remember to change all of the signs after it. And I don't know if I explained this on this video, but I circle the signs that I'm actually going to use because, like with this being a plus sign with a minus above it, you might get confused on which one you're using. So that's why I circle them. Now we need to combine our like terms in the numerator up here. So looking for the highest degree, 2x squared. Now I have negative 2x and negative 3x. Those are like terms, so negative 5x and minus 3. Divided by x plus 1, x minus 2, x minus 1. Okay, so our next step is to see if we can simplify this. And in order to simplify this, we would need to look and see if we can factor the numerator. So I'm going to do this over here. 2x squared minus 5x minus 3. So a times c would give me 2x times negative 2x squared times negative 3. So negative 6x squared. The ways to get negative 6x squared are 1x and negative 6x, 2x and negative 3x, or changing the subtraction signs. Does one of these give me negative 5x? Yep, sure does. So it looks like I can factor this. 2x squared plus 1x minus 6x minus 3, group, x, 2x plus 1, negative 3, 2x plus 1, right? Okay, so then this simplifies to be x minus 3 and 2x plus 1. X minus 3 and 2x plus 1 divided by x plus 1, x minus 2, and x minus 1. Okay, and our last step is to see if anything will cancel legally. I don't see anything that will cancel because this is a 2x plus 1 and that's just an x plus 1. So nothing will cancel. So that is our final answer. Last page. Okay, one of these two would probably be good for you to pause and try to do on your own. So pick one of the two and pause the video and try to work it out by yourself. On this first one, we need to factor the denominator as always. So x plus 4, I don't see a common denominator. I don't see anything I can take out. 5x, oh, so I should, I guess, write that. 5x, again, there's nothing I can take out. And on this one, x squared plus 4x, they have a GCF. So we'll take out my x and make this x plus 4. Okay, so common denominator, x plus 4. And notice I'm leaving some space in front of that because I know that this next one has a 5x. Okay, now this last one has an x. Do I already have an x that's not being added to something? Yep, that x. And it has an x plus 4, which I already have. So my common denominator is 5x times x plus 4. So what is this piece missing? It's missing a 5x. So numerator and denominator will have to be multiplied by 5x. This piece is missing an x plus 4. That barely fits in there, sorry. And this piece is missing a 5. So now before we distribute and whatnot, take a pause. Do we have any pieces of our common denominator that have x's? Yep, we've got 2. So set them not equal to 0 and solve. So x cannot equal 0. And x cannot equal negative 4. Okay, now for the distributing. So, or just multiplying, I guess, on this one. 5x times 1. Going to be 5x. The denominator is going to be 5x and x plus 4. Here I do have some distributing, but it's just a 1, so it doesn't change anything. So my numerator is going to be x plus 4. My denominator is going to be 5x times x plus 4. And here I have some multiplying. 3 times 5 is 15. And my denominator is now 5x and x plus 4. Okay. So now that all my denominators are the same, like the chocolate, I can figure out what I've got. So we can add all this together. The denominator will be 5x and x plus 4. So looking up here, like terms with the biggest degree. So I've got a 5x, it has a like term of x, so that's 6x. I've got a 4 and a 15, so that's a 19. So now I need to look and see, does this simplify? 6x and 19. 19 is a prime number, so there's nothing that I can take out of there. So then if it doesn't simplify, can anything cancel? No. So this is our final answer, along with x cannot equal 0 and x cannot equal negative 4. Okay, last one. If you haven't done so already, really truly do pause the video and try to see if you can do it on your own, because you're going to have to be able to do it on your own on your homework, and it would be nice to get immediate feedback on if you're doing it right or wrong, not waiting for someone or Math Excel to tell you if you're doing it right or wrong. So first step, as always, is to factor the denominator. This x minus 8 doesn't have any GCF, so I just bring it down. X squared minus 64 is a difference of squares, x plus 8, x minus 8. And minus x and x plus 8 doesn't have anything to factor. Okay, so that is factored. What is our common denominator? For my first fraction, I have x minus 8. For my second fraction, the new information is x plus 8. And for my last fraction, I have an x plus 8, which I already have, so no new information. So what pieces are we missing? Well, from this fraction, I'm missing an x plus 8. From this middle fraction, I'm not missing any information. And from this last one, I'm missing an x minus 8. Okay, so now we need to do our restricted values. So x cannot equal 8. And x cannot equal negative 8. So now when we have this is a FOIL, or a distributing problem. So we do x times x and get x squared. X times 8 is 8x. And it will be over my common denominator, x plus 8x minus 8. This middle fraction doesn't change at all because it wasn't missing any pieces, so we just bring it down. And this last fraction, we distribute in the numerator, keep the denominator the same, because that's my common one. So that's going to be x squared minus 8x. Okay, so now I would normally start to combine my like terms. So plus sign, I can just go ahead and combine these. But looking here, I have a minus sign. So I have to change that to a plus, and remember that changes all of the signs that come in the numerator after it. Numerator only the one after it. So now I can combine my like terms. So I have an x squared and a negative x squared. So those are gone. So I have an 8x and another positive 8x. So 8x plus 8x gives me 16x. And then this 2 is just chilling there by itself. It doesn't have any like terms. And my denominator is x plus 8, x minus 8. Now we need to see if we can simplify and cancel anything. So in the numerator, it looks like we have a GCF of 2, which would give me 8x plus 1. Okay, and the next thing we need to do is see if we can cancel anything legally. Well, I have 8x plus 1, x plus 8, x minus 8. I don't see anything that will cancel. So that will be my final answer along with my restrictions of 8 and negative 8.